I'm going to make a couple of videos about this second formative just to really try to clarify a few of the important ideas that we have on this topic. Our introduction to functions. And I want to begin right here with question number 2. And what I've done here is well, we're asked to list some of the key features of this graph over here. And I've started off by putting an asterisk next to these 5 things. And the reason I put that there is I wanted to just note that these 5 things, the minimum and the maximum and the x and y intercepts and the inflection points, are actually points on the graph. And the other things are we're going to describe like intervals over which the graph is increasing or decreasing, or the domain and the range in this case are intervals of numbers. And so we're going to begin just by locating these points. And the first thing about the x-intercepts that I want to point out is that there's just one x-intercept here. In other words, the graph is not horizontal in this region. If I zoomed in right here, and of course we can't really do that, but I would get something that kind of looks like this. And so notice the graph is decreasing until it gets to this point where it levels out, and then it continues to decrease from this point. So there's only one x-intercept here, and I'm going to put that on my list of x-intercepts. Notice I use the x and y values. Similarly, for this x-intercept over here, I'm going to list the x value and the y value because the x and the y-intercepts are points, and we should include the x and the y values that is, we should write the entire ordered pair when we locate a point on the plane. The y-intercept is pretty easy. It's right here. We've got to do a little work with our scale, noting that each box is worth a tenth. So this is -1, negative 1.1, 1.2, and about negative 1.25. So my x value is 0, but my y value, negative 1.25. And the inflection points are a little bit tricky. I know that that's kind of a new concept for us, but in fact, before we get there, let's talk about the maximum and minimum, and then we can, in the context of a maximum and minimum, we can understand a little bit more about what an inflection point is. So the maximum, of course, is where the graph achieves its highest possible output, which is this point. And, reading the scale, I see that the x value is somewhere between 0.5 and 0.6. I'm just going to say 0.55. I've been told to estimate when necessary. That's a good estimate. And then the output looks pretty darn close to 0.5 to me. So this is the value of x where the maximum is achieved. And this is the actual maximum value that is output by the function. And so I'm including both of those as an ordered pair. And if I was asked for just what's the maximum value of the function, I could just say 0.5. And if I was asked at what value of x is the maximum achieved, then I might just say 0.55. But I'm not asked for any one or other piece of information, so I'm including both. Similarly, my minimum, that is the lowest possible point on this graph, which is achieved right here. And again, I got to do a little work on my scale and a little bit of estimating to see that the value of x is 0.15 and the value of y is negative 1.4. And again, I'm reporting both of those. And just thinking about that minimum for a second, what's really happening is if we read the graph from left to right, the value of the function is decreasing, 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 and it gets to this minimum point, and then the value of the function starts to increase, 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 and that's what a maximum is. So you would expect that, like in the case of this minimum, this is where the graph switches from decreasing to increasing, which is going to come up down here for us for sure. But let's think about what an inflection point is. Now, it's not when the graph is decreasing, because it's actually where the graph switches from being concave up to being concave down, or vice versa. And so just a little bit of a reminder, like concavity, this section of the graph right here is definitely concave up. It's like a cup that you could fill with water, and it's pointing upwards like this. And then if you look at this section of the graph, it's definitely concave down, and it's pointing downwards. So there must be some point in between where it switches from being concave down to being concave up. And we can use calculus to determine exactly where that point is, but we're not. This is not a calculus class, so instead we're just visually kind of choosing a point somewhere in here. And any point in here is an acceptable location. And I might make my life easy and just pick a point that's on a nice corner of my grid, so that I could say that this is where the graph switches from being concave down to being concave up. You could have chosen a point anywhere in this region, and you'd be right. We can't tell exactly where it is just from the graph, but I'm going to choose that point, and that happens at negative 0.3, comma, negative 0.6. And so that is one of my inflection points. And I might also just, to connect this to sort of the idea of a maximum, it's at that point right there that the slope of the line, or the slope of the curve, reaches, it stops decreasing and starts to increase. And let me show you what I mean. If I move along this curve from negative to positive in the positive direction, the slope of the line is decreasing. It's getting more and more and more negative. It's getting more and more and more negative. And when I get to that inflection point, that's the minimum value of the slope. And then it starts increasing. The slope gets less and less negative, and eventually it gets all the way to 0, and then down here it switches from being 0 to positive. So from this inflection point, the slope is increasing, and up until this inflection point, the slope is decreasing. And that's what causes concavity. It's about how the slope changes. So there's another point where that happens. Look at this point right here. That's also an inflection point. It's an x-intercept and it's an inflection point. And notice what's happening. The slope is kind of negative right here, and then it starts decreasing. It starts decreasing. It starts decreasing. It gets to 0 right here. Okay, let me start again. The slope is increasing. It's negative, right? And it's less and less and less negative, less and less and less negative. And it gets all the way to 0, and then it switches. The slope starts to increase, increase, increase. So this point also is a point of inflection. And those are all of the important points of this graph. Let's talk for a little bit now about the various intervals that we can describe. So first of all, the domain. That's all of the possible x values that that our function takes as inputs. And it goes from this x value all the way over to here. And so I'm going to use interval notation as opposed to set notation. It doesn't tell me what type of notation to use, but I do want to be clear about which variable I'm talking about. So in the domain, I'm talking about x. And so x is any number that's on the interval from negative 1.5 all the way up to like 0.55, including that 0.55, because I got a closed circle right here. This is an open circle, so I'm using the parentheses. I don't want to include that particular endpoint in my domain. And for the range, I'm just going to use y. And this is a little bit new. We haven't talked about using the x and the y in this case when we use interval notation, but it's helpful in order to make sure we know what variable we're talking about. In the range goes from this is the maximum possible value here, and this is the minimum possible value here. And so I can pick those values right out of my maximum and minimum points that I located. And I'm going to start at the bottom of my range, the minimum value that is, negative 1.4. And I'm going to go all the way up to 0.5. And I'm including those two endpoints as well. And finally, here we go with these other intervals. Where is the graph increasing? Where is it decreasing? And where is it concave down? We report these things in terms of the values of x over which the graph is increasing or decreasing. So these are also all going to be over some interval of x values. And so increasing, the graph is actually decreasing all the way to here, and then it begins increasing all the way until this end point. And so I would say that starting at this point, where x is 0.15, and going until this point where x is equal to 0.55, that's the interval over which it's increasing. And notice I did not include these endpoints. I used parentheses instead of brackets. And the reason is because the graph is not increasing at this point, right? It's actually, that's right, the only point where it levels off, and then it starts increasing. And I don't know what's happening here. If I wanted to know if the graph was increasing, I'd have to know whether it was continuing up this way or if it goes back down this way. I don't know how the graph would behave after this because I don't have any information on that. So I'm not going to include that as a point where the graph is increasing. And at first glance, and what I said earlier in the video was, oh, the graph is decreasing all the way from here to here, which is mostly true. But it's actually not decreasing right at this point. It gets flat, and so it stops decreasing, and the slope right at this point is 0. But instead of increasing after that, it continues to decrease. So that's kind of a strange behavior right there. So if you said that this graph is decreasing from negative 1.5, x equal to negative 1.5, all the way to 0.15, then I gave you the point. But to be really clear, and some of you did this, and I was very impressed. You said, well, the graph is decreasing from x on the interval negative 1.5 to negative 1, and then it starts decreasing. It continues to decrease from negative 1 all the way to where x is 0.15. And I don't include that endpoint either. So that is technically the most correct answer that we could give here. And then finally, where is the graph concave down? And it's only on this interval. Over here it's concave up, and then over here it's concave up. But between these two inflection points, from where x goes from negative 1 until what I said was negative 0.3, something around there, that's where the graph is concave down. I hope that helps understand some of the key features of this graph, and part 2 of this series will go through the following problems.